Subscribe to AmpCode and ring the notification bell to get the latest content.
Hello and welcome back to the channel. So this is all about hands-on tutorial on Apache Spark, DataFrame, as well as the Spark SQL operation. So in the previous lecture, we have seen all about what are the high-level APIs, which is nothing but the Apache Spark SQL, as well as the DataFrame API. So these high-level API are nothing but built on top of the RDD, which is the core API of Apache Spark, which gives us the capability to work with the relational data. Relational data means it is in the structured way, which means that the data is stored in the rows and column fashion. So basically, this tabular data, you can relate it as a SQL table. And data frame is nothing but a structured table on top of your data. So you can create your data frame on top of all sorts of things. You can maybe create it on top of the CSV file, or else if you have a JSON file or the Parquet file, you just have to provide the format when you are creating the data frame. And if you have a sample data lying around that we are going to see in this lecture, so without wasting any time, let's jump on to the Jupyter Notebook. So I hope you already set up the Jupyter Notebook on your local system so that we can get our hands dirty and learn all about the pyspark data frame as well as Spark SQL operations in detail. So without further ado, let's jump into this. So as you can see in this notebook, the first step of every Spark application is creating a Spark session. But before that, you should first import all the necessary modules that are required in your Spark execution. That's we have done here. So we have imported the Spark session from the pyspark.sql as well as some functions which we require down the line in this application. So once you execute this, as you can see, it is executed quite fast. But the next step is very crucial, which is creating a Spark session. So here we are going to use a builder method, as you already know, for creating a Spark session, and we are going to store it in the Spark variable. And here we can pass some arguments, which is nothing but the app name, which is the application name. So it will get handy when you're dealing with multiple applications which are submitted on the cluster, and you can just go ahead to monitor your job on the Spark UI, and you can search your application using the app name. This is so convenient. So basically, our app name is nothing but a Spark SQL demo, or we are, and also we can use like the master as well as the specific configuration which are suitable for your Spark cluster. And here we are using the get or create method to get the existing Spark session of your application or create a new one for you. So since we have just started this, we don't have any Spark session created. So just execute this. It will take maybe 1 or 2 minutes depending upon the performance of your cluster. So as you can see, the Spark session is created, and we can use this Spark session down the line while you are dealing with the data. So basically, we have the sample data, and here we got the data in which we got the list of the data having the values such as the employee name, its age, as well as the job role, or we can say the department of that employee. So basically, what we have is the 4 rows and the 3 columns, the name, age, and the department of that employee. So basically, we can store the actual data inside our data, and the columns are nothing but the list of columns, the list of column names separated by comma. So basically, if you know Python, you know how to deal with it. So basically, the next step is you have to create a data frame on top of your data. So our data frame is nothing but the df, and we are using the create data frame operation here, and we are passing the data as well as the schema. So basically, schema is nothing but the columns of your data frame. And here, as you already know, that it will assign the data types according to your data. So basically, Alice, and basically the name and department will be having the string data type, but the age will have the integer type because it's in the integer format. So basically, we are using the create data frame method in the Spark session. But if you have a CSV lying around, you can use that using the spark.read method. So if you have a CSV or a JSON file, we just have to go spark.read.csv, and you can pass it the path of that file in your local system or the cluster. So that you can do, and also you can get control of your schema. So if you want to programmatically assign, and or else you can maybe say manually assign a schema, you can also infer that by giving the proper data types and if that column should be nullable or not. So that you can do, or you can just set the infer schema to true, so that Spark will able to identify the data types of those columns And if you have a header file, then it will automatically assign the header to the column names. So this is very convenient for creating a data frame. So once you create a data frame, so just run the sample data as well as we'll create a data frame. So as you can see, the data frame has been created. So the next thing is, if you want to apply some SQL queries, or if you want to run some SQL queries on top of this data frame, then you can either create a temporary view on top of the data frame, or you can else create a temporary table. The method is that create or replace temp view, or else you can use create or replace temp table. So basically, these temporary views and tables are tied only to your Spark session. So let's say if you have created the employees view here, so this temporary view will only be assigned to your specific Spark session, and you cannot access that in the another application where we have another Spark session. So basically it is tied to your application only. So here, as you can see, we got the create or replace temp view, and we have created the view named employees here on top of the data frame. So once you have the view, it will act as a SQL view itself. So if you have a view or a table in SQL, you can directly pass SQL queries on top of it in the query editor. But here we don't have the query editor, but else we have the capability to run SQL queries with the spark.sql method. So here, as you can see, we got our query 1. So query 1 is nothing but a string, and we have defined the query here. So what we are going to do is we are just going to select the name, the age of the employees from the employees view, which we just created, where the department is engineering. It's pretty straightforward. So if you know SQL, you know how to deal with the Spark SQL and run query on top of your data. So the first thing is just create a temporary view, and after that we'll just provide the SQL query. And this query 1 is nothing but going inside the spark.sql. So as you can see, we are passing the query 1 inside the spark.sql. We'll just execute it, and there you go. The result 1 is nothing but the another data frame which is created on top of this SQL query. So the result of the SQL query is nothing but your newer data frame, which is the result 1. So since you already know that data frames are immutable and you can only create the new one with transforming the existing one. So that's what we did here. And also you can use all sorts of SQL operation here. So here you can use the group by method to aggregate it, as well as you can use the order by method as well. So here all you have to do is in the query 2, we got the department and the average age in the particular department which employees have as the average age. So basically we'll be having the department and the average age of those employee which belongs in that particular department from the employee. And you already know about the SQL clauses, which is group by and order by, where we are using the descending order for the average age. And that's it. We are just passing it into the spark.sql, which is resulting into our result 2 data frame. So these both data frames are getting created here, but we can also run all these operations with our native data frame functions as well. So here we can use the data frame methods. So as you can see, we are performing the data frame operations here. So as you can see, we are creating a result 3 data frame on top of our DF. DF is nothing but a starting point which was our initial data frame, and we don't have to create a temporary view on top of it because we can directly use DF to transform it and convert it into our required data. So as you can see, we are just selecting the name and department here, and we are just filtering it and on the column age, which is greater than 30. So since it is an integer state, you have to just make sure that you're matching the right data type with the right value. So here we are just selecting the name of the employees as well as its department where their age is greater than 30. So as you can see, we'll just execute it and it will get completed. But in the next one, what we are going to do is we are going to use with column method, which is useful for creating a new column with some conditions. So as you can see, we are generating a status column, which will be the new column in our data frame. And we have some expression here. So here we have the case statement. So if you know about SQL, you know about what is the capability of the case statement. It is very simple to understand, but it could be wondrous and very time saver. So case statement is used when you have to deal with multiple conditions and you have to derive some value in the select clause, or else we can use differently as well as per your requirement. So basically we are going to use it for generating our status column. So when the age is less than 30, then we are just assigning the value as young, else we should assign it to the mature value. It just makes sense, right? So here we are generating a status column. So if we just execute this, all our 4 data frames are created. The first 2 were created based using the Spark SQL, but on the result 3 and 4, we have used our native data frame operations. So you have just covered everything, everything related to the data frame operations as well as the Spark SQL as well, and how to create new data frame by transforming the data as per your requirement. So basically, if you just run the show for all it, we will just get all the results here. As you can see, the result 1 is running. It will take maybe 2 or 3 seconds more depending upon the system performance. So there you go. We got the name and age. The first condition was we have just selected the name and age of employee where the department is engineering. And the next result is we got the department and average age in that particular department, which is the result of our second data frame. And the result 3 is running now. So as you can see, we got the name and the department of all the employees which has the greater than 30 age. So this just makes sense. And in the last stage, we are generating a new column here. So as you can see, we got our all employees, the name, age, as well as the department of those. And we got the status of their age, if they're mature enough or not, or if they're young, depending upon the age bracket that they have in our data frame. So this is very simple. And once you got everything done, you can just stop your Spark session. It is just simple as that, so that it will not have any resource consumption on the server side. So this is how you can work with the Spark SQL and the Spark data frame.
So that's it for today. I'll see you in the next lecture.